Okay, well, I'm going to get started. Thank you all for being here. This is a public webinar entitled Diagnostic Resource Teams to Support the Physics Validation of Potentially Transformative Fusion Concepts. I'm Scott Hsu, Program Director at ARPA-E at the Department of Energy. Before we start, this webinar is being recorded and will be posted publicly on the ARPA-E website. Everyone is being muted during the webinar. Instructions for submitting questions and comments will be provided at the end of the webinar. The purpose of this webinar is to present ideas on a potential ARPA-E targeted topic funding opportunity announcement for the formation of diagnostic resource teams to design, implement, and field diagnostics to validate the performance and identify issues of ARPA-E supported, potentially transformative fusion energy concepts. There's no funding opportunity at this time. This is for discussion and information gathering. We would like to solicit input and comments from the fusion R&D community to help us gauge potential interest, maximize impact of this potential effort, and to identify pitfalls. This is an outline of what I'd like to cover. The objectives of a potential targeted topic funding opportunity announcement for fusion diagnostic resource teams. A very brief review of the RPE Alpha Program, which was the Accelerating Low-Cost Plasma Heating and Assembly Program. There's further information at this web link below. Then I'll provide further information on this potential FOA, and then finally instructions for submitting your questions and comments. Please do write them down as we go along so you don't forget. I'd like to also refer you to posted slides that I recently presented at the Fusion Power Associates meeting. This will provide further context and background on the RPE Alpha Program as well as the fusion mission space at ARPA-E. The immediate objectives of this potential targeted topic are firstly, validation of RPE projects showing evidence of promising fusion performance. By this, typically, I mean electron and ion temperatures potentially above a 500 eV to keV level and evidence of thermonuclear DD neutron production. Secondly, to leverage the expertise of the larger fusion R&D community. So on the left, this would help provide justification and excitement for next ARPA-E fusion program pitch. Equally importantly, it would identify potential issues before further major investments are made in these concepts and other ones. We'd like to stimulate the design and implementation of traveling diagnostics to stretch limited resources. On the right-hand side, we wish to encourage mutually beneficial exchanges between public-private fusion enterprises, build the foundation for public-private partnering for potential next ARPA-E fusion program and beyond, obtain best-in-class measurements and avoid reinventing the wheel by each project. And finally, we'd like to help refine metrics and methodology by which fusion concepts are judged. So the ARPA-E Alpha Program, which was executed largely between 2015 and 2018, aimed to catalyze low-cost fusion development pathways toward commercial fusion energy. The technical outcomes of the program can be summarized as follows. There were performance advances in several transformative fusion concepts. There was demonstration of novel, scalable technologies that could potentially enable new concepts. There was development of innovative experimental platforms to study crucial fusion R&D issues at relevant conditions. It's worth mentioning that Alpha focused on pulsed intermediate density concepts, but going forward, I anticipate a broadening this out to not to restrict it to pulsed intermediate density concepts. There were also technology to market outcomes, which is an important part of ARPA-E programs. There were 3 new spin-off companies from the 9 Alpha projects. There was $25 million in private capital raised by Alpha projects during the Alpha program, in comparison with a $30 million total federal investment. There were dozens of peer-reviewed publications and 6 patent applications. These are some examples of ARPA-E supported fusion projects that could benefit from this potential program in the next 1 to 2 years. Firstly, there is the FUSE experiment, the Fusion Z-pinch experiment at the University of Washington in conjunction with ZAP Energy. Theirs is based on the flow shear stabilized Z-pinch. There were various experiments conducted at different facilities led by the fusion company MIFTY, based in Tustin, California. They have conducted experiments at the Nevada Terawatt facility in Reno, Nevada, at the Cobra facility at Cornell, and also at UCSD. Their concept is based on the stage Z-pinch, which is a gas puff liner compressing a gas puff Z-pinch. There's the fusion engine concept, that of Helion Energy. They are pursuing magnetic compression of merged field reverse configuration plasmas. There's the Princeton FRC experiment pursued by Princeton Fusion Systems and PPPL. Theirs is an FRC sustained and heated by a rotating magnetic field. And there's the HIT-SI 3 and upgrade pursued by University of Washington and CT Fusion. And theirs is based on a Spheromax sustained by imposed dynamo current drive. So these potential diagnostic resource teams, or the proposal teams, could support these and hopefully other fusion projects, both federally and privately funded. I'd also like to mention that I have spoken specifically to the PIs of each of these 5 projects, and they are very much on board, with what I am presenting today. So the ARPA-E fusion projects are earlier stage in the fusion development path. And as such, the highest priority needs are to validate the basic plasma parameters, the stability, the power balance, the energy confinement time, and the neutron spectrum. And thus, these are the immediate near-term priorities. So in this table, I'm showing the quantities of interest in the near term as well as their approximate range of values for which we would like to conduct measurements, diagnostic measurements. And broadly speaking, we're distinguishing the concepts into 2 classes of approaches. So the longer pulse magnetically confined approaches and short pulse imploded intermediate density approaches. And they each have different parameter ranges and requirements. I won't be reading off all the values, but you can see them there. The experiments as they exist today predominantly are in these ranges of values. Of course, we would like the ranges to go beyond what they are today in anticipation of future performance. I'd like to mention that in addition to the plasma parameters, as you see there, some of the concepts are producing evidence of thermonuclear DD neutron production. For the neutron measurements, they do span various durations, even within the imploded concepts. These are predominantly DD experiments. The main need here is in distinguishing between thermonuclear neutrons and beam-produced neutrons. And so the measurements, any measurements which can help distinguish between those are needed. Also point out the desired time and spatial resolutions for these different classes of experiments, as you can see there in the table. Many of the experiments do have diagnostics getting at some of these parameters, but most of the experiments would need increased spatial positions and better resolution, both time and space. But some of the experiments have much more limited diagnostics, and so further details would of course be included if and when an FOA is released. So some more details. The potential FOA will identify priority near-term measurements, as well as further details about the experimental access, etc., for each class of experiments. And as I mentioned, they each have different needs and constraints. The metrics will likely focus on versatility, adaptability, transportability of a diagnostic per cost, the schedule to first and subsequent measurements, the demonstrated experience and success of a team and their proposed systems, and minimum development, i.e., in this proposed program, the innovation will be in the adaptability and transportability of the instrument, not its diagnostic methodology. In other words, we are not looking to fund advanced diagnostic development. We would like to utilize proven diagnostic methods in this context. Our intent is to facilitate interactions between the working proposal teams and these fusion concept project teams. We would like the diagnostic teams to help with data collection and analysis and be lead or co-authors on scientific publications. And hopefully the selected teams would be well positioned to compete in potential future fusion programs at ARPA-E and elsewhere, with the potential of expanded efforts in these types of diagnostic resource teams and needs. The potential size and duration of awards between, say, $100,000 to $3 million and up to half a dozen awards, spanning this range of award size, and obviously to depend on the cost and complexity of the diagnostic being proposed. We're looking at an aggressive timeline, 12 to 24-month periods of performance. We would like early validation of the performance of the projects mentioned. Early results will be heavily encouraged. There's two major needs, and a proposal team could fill either one or both. The first would be traveling diagnostics, for example, to design, build, and bring a complex and/or expensive system, such as Thomson scattering or a 24-frame intensified imaging system, to multiple experiments. Or a second need could be a design consultant, for example, to help with the design of lower cost, less complex systems that may be permanently installed at one or more experiments. But in both cases, it would be desirable for the proposal teams to help with data collection and/or analysis and be co-authors on scientific papers. Potential future ARPA-E fusion program may support many diagnostic resource teams, each with up to multi-million-dollar awards. So I think of this effort on the targeted topic of diagnostics as a pilot program for potential expansion in the future. So the timeline, to repeat, there is no FOA at this time. However, if an FOA is approved, we hope to announce it as early as next month, February 2019. Full proposals would be due 60 days later. Maximum proposal length 14 pages. The intended eligibility are US-based teams to include national laboratories, universities, small and large businesses, and/or combinations thereof. So please email your questions, comments, and constructive criticisms to colleen.neal@hq.doe.gov by January 31st this month, if at all possible, with the subject line Fusion Diagnostics. In particular, we hope your questions, comments, and criticisms would help us write the best possible FOA to maximize the impact of this effort. And so with that, I would like to thank you again for your time and participation. and also those of you who may be viewing a later web recording of this. I thank you again, and please do send us your comments and questions. Thank you again, and this concludes the webinar.